The Earth is the only rocky planet in the Solar System with a large natural satellite, the Moon, while Mercury and Venus do not have any and Mars has only two small irregular satellites similar to asteroids. The Moon, however, is a true satellite with significant dimensions compared to the Earth, larger than all the dwarf planets and so important that the Earth-Moon system is defined as a double system, since its influence could have contributed to the long habitability of the Earth by stabilizing the inclination of its rotation axis. Understanding whether having such a large moon is an exception or rule in the universe requires exploring its origin. The first modern hypothesis was proposed by George Darwin in 1879, suggesting that the moon had detached from the Earth due to its rapid rotation, but this theory was later discarded because it does not explain some observational data, such as the moon's orbit not aligned with the Earth's equator. The hypothesis of the capture of the moon is also considered unlikely, because it would require extremely precise conditions and an effective mechanism to slow it down. Furthermore, lunar rocks have an isotopic composition practically identical to that of the Earth, suggesting a common origin, but the hypothesis that the Moon and Earth formed together in the same region of the protoplanetary disk is denied by two elements: the small size of the lunar metallic core compared to that of the Earth and the high angular momentum of the Earth-Moon system. The most widely accepted hypothesis today is that of a giant impact. About 4.5 billion years ago, an object the size of Mars, called Theia, would have hit the Earth still in formation, generating an enormous quantity of debris that would have formed the Moon. This theory, supported by computer simulations, explains the angular momentum, the composition of the Moon poor in volatile elements, its small nucleus and the greater density of the Earth, perhaps due to the incorporation of the metallic nucleus of Theia. However, some details, such as the exact dynamics of the impact and the identical isotopic composition of Earth and the Moon, remain to be clarified, and future space missions may provide valuable data to understand whether a large satellite like the Moon is essential to making a habitable planet.